CH single bond, CH double bond, CH single bond, and it goes in a circle. And the molecular formula is C3H6. Percent composition of H is 14.4%. Percent composition of C is 85.6%. Benzene is HC single bond, CH double bond, CH single bond, CH double bond. Goes in a box. Is C6H6. Percent composition of H is 7.8%. Percent composition of C is 92.2%. Cyclobutadiene, whatever. HC triple bond C single bond CH2 single bond CH2 single bond C triple bond CH. C4H4 is the molecular formula. Percent composition of H is 7.8. Percent composition of C is 92.2. Hexadiene is molecular formula C6H6. Percent composition of H is 7.8, and the percent composition of C is 92.2. Critical thinking questions. 3. Verify that the percent composition of C and H given for hexene in table 1 are correct. For carbon, 6 times 12.0 over 6 times 12.0 plus 12 times 1.01 times 100 equals 85.6. For hydrogen, it's 100 minus 85.6 equals 14.4%. 4. Fill the blanks in the table 1, which we did in table 1. You can see that, the red spots. 5. Can you determine the compound structural formula if you are given the molecular formula? Explain. No. For example, hexane and cyclohexane have the same molecular formula, but different structural formulas. What is true about the percent composition of two different compounds that each have the same molecular formula? If two compounds have the same molecular formula, they will have the same percent composition as well. 7. Can you determine the molecule's molecular formula solely from the percent composition? Explain. No. As can be seen in table 1, compounds with different molecular formulas may still have the same percent composition. 8. Using only the formula in table 1, no calculation of periodic tables, predict the percent composition of each of the following compounds. Molecular formula C8H8. Percent composition of H is 7.8. Percent composition of C is 92.2. C10H20. Percent composition of H is 14.4. Percent composition of C is 85.6. Note: any compound with a 1-to-1 ratio of carbon to hydrogen will have a 92% carbon and a 7.8% hydrogen. Any compound with a 1-to-2 ratio will have an 85.6% carbon and 14.4% hydrogen. Empirical formulas. An empirical formula is a formula that describes the lowest whole number ratio of elements in a compound. An example of an empirical formula is CH, which the empirical formula for benzene, whose molecule formula is given in table 1. Critical thinking questions. What is the empirical formula of a compound whose percent composition is 92.2% carbon and 7.8% hydrogen? See question 8 in table 1. The empirical formula for CH as determined in question 8 and table 1. If you know the percent composition of each atom in a molecule, then you can determine the empirical formula for the compound. Yes, you can, although right now you may not be sure exactly how to do this. Calculate the empirical formula. When you know the percent composition of each element in a compound, you can calculate the empirical formula of that compound. The following example will illustrate how to do this. Example 1. A certain compound is 30.4% nitrogen and 60.6% oxygen. Divide each percentage by the molar mass from the periodic table. Oh. Step 2. Find the ratio of nitrogen to oxygen. Do this to find the smallest number obtained in step 1. In this example, the smallest sample is 2.17. Now divide each of your answers by the step 1 and by the smallest number in this example. If you should divide each answer by 2.17. For nitrogen, 2.17 over 2.17 equals 1. For oxygen, 4.35 over 2.17 equals 2. Step 3. Write the formula, no answers.